All right. Next up, we have Fabio Andrijauskas to talk about the Open Science Data Federation.
Can you hear me? Yeah. Good evening, everyone. And I'd like to start in a very serious manner with something. I think it's not the focus on this. Yeah, thank you. And I create this joke and nobody laughed. I want to check in a few 30 seconds if someone is gonna think is funny or not. Nobody's laughing. Okay. I told this joke for several people and nobody laughed. I think it's not working. Okay, I give up my comedy. I will start keeping science. I think it's better. Anyway, I will talk about the Open Science Data Federation and the National Research Platform. And I like to say a little bit about the Pelican, the OSDF. But the Pelican here is the magic layer in the OSDF who create access and create how to get the objects, give authentication, and give the whole process. And with the beginning of the OSDF, we just have one component here, was a redirector from XRT. We do have some authentication. We rely on the topology, some tokens. Was a simple infrastructure, works, but was a little bit simple. With Pelican here, we have the registry. When you create a new cache, a new origin, you need to go to a service and say, hi, I am the origin. I'm going to provide that, that, and that. Or the cache, we have more control. Is a healthy environment because you can control way more stuff than the previous OSDF version. And besides that, we have new layers of data because in the very beginning, we just have the XRD and the POSIX storage. That's our main layer. Right now, you can access data from S3, Globus, and other interfaces, and that provide way more ways to create access for the data we really need for the jobs and everything else. Besides that, with the OSDF right now, you can use to run jobs like HT counter, but you can use to get data from your own laptop. You don't need to rely or be stuck in a job. You can just stage your data over there and get this data from wherever you want using a simple and a very common protocol as HTTP. It's very helpful, very useful, and breaks a little bit how complicated sharing scientific data is. It's a very healthy and good environment to work to provide data and everything else. This is the OSDF map. We have hosts all over the planet. We have a huge part on the US. We have some on Europe, providing special data for specific projects. We have support from Internet2, from ESNet and other networks to provide even the caches and the network, and that creates for us a very interesting layer of data management and data delivered. And we have partners. That's very good because they need to control everything. We need to control the software, some part of deployments, but the network layer and other aspects, we have ESNet, Internet2, they can help us a lot trying to figure out problems and trying to figure out ways to provide data in a very better way. We have caches in Brazil, Japan, especially for Lego and the Kagra detector, Singapore, and we're trying to bring one to Africa to abroad or data experience and our data facility way to create access to this information. And with Pelican, we create more than just a layer of how to get data. We create more ways to get how the origin is. One simple example, in the very beginning, we have 2 ports on the origins, one to provide authenticated data, another one to provide unauthenticated data. And now we have 2 ports, one to provide data, no matter what, and you have a web interface. And use this thing, because if you are not in administration of the server, we can ask the admin, okay, log on this web page and just say to us what you're seeing. If it's green, if it's red, what's the problem? And you can debug this way better than just looking logs and trying to figure out by your side. The admin on the other side can literally check and say, okay, everything's green or everything's red. It's way easier to figure out what's going on if something is not working. Especially now we have the director, and in the directory you can see if the cache origin is healthy or not. And that helps a lot in the process of keeping the federation working. That's very, very helpful to everyone. As was shown here, we have how to access object. Now it's just Pelican, object, get, and you can ask for the job. Especially here, we have in the OSDF, we have several caches all over the place. And the Pelican created a very elaborated and very effective algorithm to how to figure out which cache you should get. And right now it's just a simple test. He figured out the closest cache were UNL, DTR Pass, and OSDF Chicago, and he got the data from the UNL. And this layer is not, you can control it if you want it, no problem. But normally when you use the Pelican client or you ask the data to the director or the Pelican client is gonna give to you the data from the closest cache as possible. It's not literally the closest one, but there is a very specific algorithm. Just explain me once, but it's kind of elaborated, need more than 10 minutes to show how the algorithm works, but it's very interesting. There is just a logic part to get the closest one, but there is a statistical part, how to figure it out and not overload something just because the closest one is a very smart way to get data from the OSDF. When you need a new cache or origin, when a user or a campus get a CC star or something like that, say, okay, I have a space, I have a storage, I want to create a new origin or a new cache for the OSDF. How can we do that? Okay, there is a classic one, RPMs. He goes to the cluster, goes to the node, install the packages, create the configuration, and that should work. That's a way to do it. We have some installations like this way. It works. We have another way, local containers. That's a little bit better, a little bit easier to maintain. You run the container, set the configurations, set the storage point, and run the thing. And you have the NRP. The NRP is a very specific project. And the NRP is a national research platform. It's a huge global-wise Kubernetes cluster providing different types of hardware and different types of storage all over the United States and some other points. There's a map I'm going to show all the points where NRP can provide data, provide processing points. And it's very interesting because if you have a hardware, you want to run some jobs, you can provide to NRP. Or if you have a project to research, you can use NRP to run your research, run your code, run your simulations, and everything else. And there is a perk. If you have access to NRP, you have free LLMs to run. You don't need to use Claude or something like that. You have several different models. If you have access to NRP, just go there, 2 clicks, you have access to a free LLM with different models, different agents to use and to interact using the NRP infrastructure to run all the AI things we need to have LLM. It's very cool, it's very interesting. It's not exactly like the commercial solution, but works exactly as it. It's very, very interesting, and it's free. That's a good perk on that. Okay, that's the NRP map. And we have a bunch of hosts here in the US, a few in Brazil, a few here in the Asia. Some are just OSDF, like Singapore, a bunch here in the US, and other places. But these all are hosts, nodes from the Kubernetes cluster. You can allocate and run your simulation, run your things you need using the Kubernetes, using the Docker infrastructure. It's very interesting. And even HD Condor, even the OS pool, we have some jobs that go and run using the NRP infrastructure. It's very feasible to run. We have a whole documentation. There's a whole team trying to help everyone trying to use the whole Kubernetes and how the thing you need to figure out how to run your job, create a storage, create a PVC, then this whole process. And we have the OSDF hosts running in NRP. And that's the thing, if you have a CC star, if you have a storage, if you have a cache, and you want to be part of the SDF, you can run your own installation, that works, or you can run using NRP. How you do that? Public IP, IPM access, root access, then I can see some security network managers looking, and oh geez, it's gonna be worst. Firewall is controlled by NRP. because we have the whole cluster running and we have to figure out what can be accessed, what cannot, then use the NRP firewall to protect your node. We have the whole system, we have a whole cluster running. We don't have a huge story of problems, but we need to convince your security team to remove their firewall and put the NRP firewall. And we do have this. We have a bunch of nodes. Someone just buy the node, give access to us, and you create the whole Kubernetes and everything else is going to be integrated into NRP. And how you deploy the OSDF hosts, caches, origins, we have in NRP to literally create the OSDF, but just the hosts we have in NRP, into NRP. We have a Kubernetes DevOps environment. It's very easy. We just go to a GitHub repository, create your configuration. You have some magic here. It goes inside the Kubernetes cluster and deploy the service to you. What that means you have a bunch of scripts here, not scripts, but configurations. And if you want to create a new cache, a new origin, it's quite easy. You go here, copy this one, and for some reason, I always copy the first one. And sometimes I'm running something, oh, Amsterdam, no, it's the wrong configuration. But you can copy this one, create a new host, change some configurations, and after 5 to 10 minutes, I am texting Brian Lin to ask something is wrong. Sorry, I was running the cache and origin. And normally in a regular NRP deployment, literally takes 10 minutes. You just copy and paste, set the configuration. If there is no firewall problem, if there is nothing else, it just runs. And you can deploy services very fast. And there is another thing. If I'm not available to change something or someone needs to change some configuration, it goes to GitHub, change the configuration, and keep the federation works. It's not something I just, me can change something or someone else. Everybody who has access to the GitHub repository can provide and can create configuration, fix problems, and debug situations. It's very healthy for the whole federation because you can literally keep the things running. That's the pod view. It's just for amusement, but we have a bunch of services here. Each line here is a pod running into NRP, providing some different services, and almost, or I think all, is running in a DevOps environment in a GitHub. You change the GitHub, go to the Kubernetes cluster, change the configuration, and keep this thing flowing. It's very useful to see if someone broke something, because you can go to GitHub and say, okay, this person messed up. And then you can just blame the person. It's not fun when it's you, but it's okay. We have besides, you have a huge monitoring from the director, directed from Pelican, and we have been running this service for a while. Is a independent checks you create to figure out there's something off, because some weird things happen. Sometimes you can see from the director perspective and it's working, but I can see some network problems. I can see different thing happens, and we have a different monitoring system all over place to try to figure out problems. And to finish that, we have some OSDF applications related to services, related to how to monitoring, how Pelican works, and everything else. That's it.
Questions for Fabio? We have one here. Another one back there.
Just a quick one about the GitOps deployment for cache. Well, two part. Also in Origin, can you deploy in Origin that way? And could I do that on my own on-prem Kubernetes cluster that's not part of NRP?
Yes.
Okay.
We can set up something. We have different clusters, and we have the DevOps environment for other clusters as well.
Okay.
And this NRP, do you have like a some amount of resources you can use, or like is there a limit on that, and what is that?
There is some limitations specific about time, how much you can use your group, but we have a bunch of resources you can like. There's limitations, but they are not that small.
And what about like the countries you mentioned? They don't include like Asian countries like Pakistan or India. So like this is only for the particular institution, right? This NRP resources is not for everyone.
If you have I think if you want to participate, we need to have a project, but it's almost everyone. Yes.
So even a person in Pakistan can request for account?
That's a question I'm not sure.
I'm also curious about the concurrency of these LLMs that you can host. Is there a max limit on the number of messages you can send to it or a number of users? And does NRP spin up replicas of each model as the scaling increases, or how does that work?
We have the model running. I think Derek is.
I could probably answer that. We do have multiple concurrent instances that are load balanced for models, for several of the models. And we do have rate limits. They're very high. But we do monitor that as well in usage.
Thank you.
All right. Thank you, Fabio.